Okay, so here we go. So this is question number 5. 2 log base 2 of x is minus log base 2 of 4. All right. So what are we going to do? What's the game plan for this? Yeah.
Couldn't you solve the negative log 2 of 4? Make it into the number?
Do what's that?
Couldn't you make the negative 2, the negative log base 2 of 4, couldn't you turn that into negative 2?
Oh, you mean move the negative on the other side? Over here? You mean multiply both sides by negative and put this over here?
No.
Why would something become negative 2? You mean this negative get on that guy?
No, because wouldn't log base 2 of 4 be 2?
Oh, yeah. You're right. Oh, you're thinking even more advanced than I assumed. Yeah, you're right. If you know that, great. You're totally right. It means that'll save you a lot of time. I'm assuming not everybody notices that, but that's a good observation, yeah. If you don't notice that, well, let me just assume you're not, because I don't think most would notice that. It's a good observation. Normally what we do is we get the logs on the same side. So let me give you a game plan for solving logs. There's room to write it here. Solving logs. Number 1, logs on the same side. You got to be a little scribbly there. Get the logs on the same side. And then we count down the logs. I don't know if I said that. Maybe I didn't. Count down the logs. That's kind of the plan. Meaning there's going to be 2 logs, 1 log, no log. I'm saying that to help you get the flow. So, all right, so when you see a log equation, that's what we're doing here in this section. We got, a couple logs, got an equal sign. It's a log equation. What we do is we get them on the same side. There's other ways, but I think it's about the easiest. Move that over there like that. Get those on the same side. So 2 log base 2 of x plus log base 2 of 4 is 0. Good so far. And now I'd like to combine those 2 into 1 log. How do I take these 2? Oh, you know what? Actually, first, I better do something about that number in the front. Yeah, where's he go? To the power, huh? Remember that third quality that that 2 will just go right up here to the power. So x squared. Yeah, so remember the 3 properties of logs. Property 1, adding is multiplying. Property 2, dividing is subtracting. Property 3, powers can go to the front or back to the power zone, depending on what we need at the moment. Yeah, so let's move that up there. Now, how can I make those 2 logs? So now that you want to think, I'm trying to help your memory. Like, see this on exam 3, April, whatever it is, 10th or whatever I said. 2 logs. You want to see, when you see a couple of logs, you want to think, okay, log count. And I'm hoping that phrase will put it on a 3x5 card, and that'll guide you. So you think, okay, I got to go 2 logs, 1 log, no log. That's pretty much what the flow is going to be. 2 logs, 1 log, no log. So first step, how do we go from 2 logs to 1 log? What does it? The property, huh? Yeah, so adding, easy job for 2 logs, just adding, super easy operation, first math operation we ever learned, adding for 2 logs, becomes times for 1. The base doesn't change, the log base 2, log base 2, log base 2, that never changes. It just continues to be the same, log base 2. That's times in that. It's a funny looking dot. It's a times dot there. So far, so good. 2 logs became 1 log. Okay. Now, so 2 log, 1 log. Next, I'm supposed to have no log. Huh? No log. How do I make that into no log? What do I do to make that into no log? What gets rid of logs? What's the opposite of a log? Powers, huh? Powers are opposites of logs. Powers, I hope there's nothing else you remember from logs this semester. I hope you remember. Powers are opposites of logs. Logs are inverse exponentials. So basically, if you have a power and you want to get rid of it, do a log. If you have a log and you want to get rid of it, do a power. They're opposites of each other, right? But you got to make the bases match. So if I want to get rid of this log 2, what will do it? 2 power. But whatever you do to one side, you have no choice but to do the same thing to the other to keep the balance. Huh? So I do 2 to the 0 on both sides. Everybody good there? All right, that's my equal sign. So these are gone. And what does that give me? X squared times 4 is 2 to the 0. What's anything to the 0 power? 1. So I'm out of the woods. I'm out of the logs. Isn't that a clever analogy? I'm very proud of that one. Logs, woods, right? You with me? Sorry, there's not a lot of good math jokes, but every now and then. Sorry, I apologize. They're all kind of lame, really. All right, so how do we solve for x there? We're out of the log. So now it's just, we're just normal algebra now, in other words, right? The log stuff is over. We're just doing normal algebra. How do we solve for x now? Well, yeah, just divide by that 4, right? Divide by that 4. Whoops, I canceled the x squared. That's not right. Don't do that. Cancel the 4. There we go. So the 4s are gone. So x squared is 1/4. Last step to solve for x? Yeah, roof on. If you go put a new roof on the house, up and down the ladder. I'm trying to help you remember. Plus and minus. Plus and minus. So x is plus minus the square root of 1/4. What is the square root of 1/4? Yeah, square root of 1 is 1. Square root of 4 is 2. So it's 1/2, huh? The square root at the top, square root at the bottom. Square root of 1 is 1. Square root of 4 is 2. So plus or minus 1/2. 2 answers, but you must check logs. Let me come up here and say logs with an equal sign. Log equations must be checked. Plug your answers into the first step. Plug your answers into the first step inside of logs, not 0, not negative. Remember that? You can never have a negative or a 0 inside of the logs. An error, if you didn't calculate an error. So it can't make the equation true. It can't really be a true answer. It doesn't even work in a log. So, okay, so I'm saying I got 2 answers here, plus 1/2 and minus 1/2. If I put the plus 1/2 in for x, remember, go back to the first step, the original, put it in for x, so that's positive, so that's fine. I don't need to work anything else out. I just have to make sure the inside of the log is not 0, not negative. Yeah, that's positive 1/2 is not 0, not negative, but the negative 1/2 obviously is bad. So the only answer is just the positive 1/2 on that. We're done. Is that okay? Questions on that? So log countdown. We get them on the same side, and we count down the logs, and at the end we check. There it is, the secret ingredients for solving log problems. All right. Two log 6 x minus 5 plus log 6 9 equals 2. So try that one. Same kind of thing. What phrase are you going to think as soon as you see a couple logs with an equal sign? I thought I made it so catchy. Log countdown, right? Count it down. 2 logs, 1 log, no log. I think that'll tell you the flow. As soon as you see it, think, okay, log countdown. 2 logs, 1 log, no log. So your next step is to make those 1 log. That 2 in the front, where am I going to go with that thing? To that power, huh? Remember, numbers in the front, that's the third property of the logs. Numbers in the front go to power. And then those are 2 logs added. So make them 1 log. What's it going to be? 2 logs added becomes 1 log multiplied, huh? 1 log multiplied. It's a harder operation for 1 log. How we doing? So let me see where you're at. Hopefully you're getting to the answer. Feel free to check with those around you, work together on these problems. Get a little more out of things. So put that power up there and then combine them into one log. X minus 5 squared times 9, like that. Adding becomes multiply for one log. Harder operation. Times is a higher level operation than add, right? Harder for one log, easier for two. Adding for two logs, multiplying for one log. Okay? So 2 logs, remember the flow, counting down. 2 logs, 1 log, no logs. So how do I get to no log now? So we're talking about getting rid of that log, right? No log. Get rid of that log. How do I get rid of that log? The power, right? Powers are opposites of logs. Exponents are opposites of logs. Yeah. So and the base has to match, so it's got to be 6, doesn't it? Whatever's the base, it's got to be the same thing both sides. Is that good?
I have a question.
Yeah.
I don't know, maybe I just did it wrong, but I skipped a step and did the 6 to get rid of the logs before doing making the x minus 5 squared times 9. Can you do that, or is that not going to work?
You did the 6 right away?
Yeah, and made it 6 to the second over there. Right? That's what you're supposed to do, right? It's 6 squared over there, right?
So, Krista, you're saying you had 2 from the you just did the 6 right away.
Yeah, from the purple one, I just did the 6 right away. And
just from
the x minus 5 squared times 9. Is that possible?
So, you just did 6 right here and right here. Well, and you just canceled out both those logs?
Yeah. Yeah, and made it 6 squared on hand.
But did you have adding then?
No, multiplied. I changed it to multiplied.
Okay, yeah, well then you're doing everything. You're doing everything.
Okay.
Yeah. That's fine.
Will that work?
Mm-hmm.
Okay.
That'll work, yeah.
Thanks.
Uh-huh.
I was like,
So, so yeah, as long as you remember to change adding to multiplying. That'd be the one trick.
Okay.
And the other side, 6 squared is 36. We good to there? So we're out of the logs. Logs are gone. Now we're just regular algebra, just normal solve for x kind of thing, huh? Okay, but that's easier said than done. What do we do there to solve for x? Yeah, divide that 9, huh? Divide that 9 totally. Divide that 9, and then that's x minus 5 squared is 4. Now, yeah, it'd be easier to root it. I mean, what you're saying is allowable also, but it'd be easier to root it. Yeah, let's just root it. So roof on the house, up and down the ladder. So now, rooting is the opposite of squaring, huh? Just like logs and powers are opposite. So that root will cancel that square. That's why we do it, huh? So I'll bring it over here then. That leaves us x minus 5. No more root, no more square. They eliminated each other like a poison and an antidote. They're gone. The other side, though, is plus or minus 2, isn't it? Because root 4 is 2. Now, we have both answers so far. I mean, we're not to x isn't quite alone yet. But 2 options, and then we have one more step. Let's finish it up. Add 5 to both sides. How do you do that? Well, you just do the 2 different options. You know what I mean? It's plus 2 plus 5 and minus 2 plus 5. Which is what? 7 and 3. Maybe. We have to check them, don't we? So see how I got those 2 answers first off, though, right? I just did the plus 2 and the minus 2. Both add 5. And so I got 7 and I got 3. Now, usually, the lower one's bad. Like if you're running out of time, middle of the test, or the homework, you say, it's got to be 7. 7, just 7. Probably, about 90% of the time. Yeah, but so they could write a problem. There might even be one in the homework, I don't remember, where they're both good. They could both be good. They could both be bad. What if they're both bad? It's no solution. So they could both be good. They could both be bad. It could be the lower one and not the higher one. It could. But 90% of the time, it's the higher one only. That's usually it. Anyway, let's go through the formalities to check. If I try the higher one, and I plug, how do you check? You plug it into the first step. You could probably just do it with your eyes. You probably don't even need to look at anything. If you just take that 7 and go back to the first step, put a 7 in there, what's the inside of that log?
2.
Positive 2, so that's good. As long as it's not 0, not negative. How about if, and that's the only x place. So the 7's a keeper. Now how about the 3? If I put the 3 in there, 3 minus 5, negative. So sure enough, like I said, 90% of the time, you keep the high one. You don't keep the low one. that good? Questions on that? Good. All right. I'll move on if you're good. All right. So log 4x plus 7 is 1 plus log x minus 4. All right. Try that one. You want to get those logs on the same side, huh? Let's get those logs on the same side. Give me a minute. Try this. I'll wander around. And if I can help you, feel free to check those around, Joe.
The way I always think of it is like division makes it smaller, and so does subtraction. And addition makes it bigger, and so does multiplication. That's the way that I think about it, to put them together. Like a little trick.
Feel free to compare. See if you're getting the same thing as those around you. Oh, I got confused. Yeah. Right. Yeah, and then put 10 over 1 and cross multiply. Yeah. You guys getting rid of once you get rid of the logs, you put that 10 over 1 and you cross multiply. Cross multiply. You guys getting that?
So now he's just put 10 on
Let me jump this over here. Get the logs on the same side. Log 4x plus 7 minus log x minus 4 equals 1. So we get them on the same side. Then we're thinking count down the logs, huh? 2 logs, 1 log, no log. So yeah, subtraction becomes division. So it'll be 1 log with these guys divided. Everybody good to there so far? Subtraction becomes division, right? If that was adding in the middle, it'd be multiply, huh? Adding is multiply, subtraction is division. Good on that? And now, so 2 logs, 1 log. Next, we got to get rid of the log completely. Yeah, what's the base here? What's the hidden base? 10. So we do 10 both sides. And these totally cancel each other out. Good to there so far? 2 logs, 1 log, no log. Okay, so then we get 4x plus 7. 10 to the 1. What's 10 to the 1? Which is 10. Right? It's 10. Now, we're out of the logs, right? We're done with the logs. We're just normal algebra now. All the fancy log stuff is over. So now, how do you solve when you got a fraction on one side and a whole number on the other? You put that thing over 1. You go diagonal, diagonal. Cross multiply. So, bring it over here. So then it is 4x plus 7 times 1 equals 10 times x minus 4. Right, just lay it flat, diagonal, diagonal, lay it flat, cross multiply. And then just distribute through the parentheses and solve for x. So that 1 will go boom, boom. The 10 will go boom, boom. That good? X is saying, I want to be alone. I want to be alone. So how do we get x alone? Subtract 4x. Just get rid of one of those x's. I would deal with the x's first. It doesn't matter. There's a lot of ways to do it. So 7 is 6x minus 40. Then we got to move the 40. Right? X is saying I want to be alone. So add the 40. Boom. So what's that? That becomes 47 is 6x. Last step divided by 6. There we go. 47, 6. Maybe. Probably. If you want to check, if you don't have time, it's probably right. To be sure, to be sure, what I would do is divide it with my calculator. I would just go 47 divided by 6. It's going to be 7 point something. So then I would take it back. Okay, if I put 7 point something in there and 7 point something in there, they're both positive. It's good. See how quick it is? Yeah, you can just kind of do it with your eyes. I mean, once you make it a decimal. Was that too quick? You see what I did? I took my answer, 47.6. I can't really think of it very well like a fraction. So I just divide it on my calculator, get 7 point whatever. And I go back and I put in the 7 for x here. And I think, okay, 4 times 7, 28, plus 7, it's not negative, right? Put in 7 here. 7 minus 4, it's not negative. So it's good. As long as it's not negative, not 0, it's good. Matthew.
I noticed on the homework, 5.5, I'm not too sure, it was towards the latter 75% of the homework itself. We had it set up in there where it's subtraction, but instead of doing division, they dropped it back down and changed it to addition. And then put it like in brackets and parentheses. I'm not too sure.
Okay,
Has anybody else experienced that?
I need.
Instead of going straight to division, like how are we working it
I
out?
totally hear you, Matthew. I just don't want to use it a lot of time. If you can find one, I would be glad to do it. But I don't want to go back and search, and I don't know.
No, that's fine. But there's a way it works that way. Like you can.
That's just too vague. I don't know. Sorry, if I knew what you're talking about. Yeah, but if you can find like the exact one, bring it tomorrow or today. Email me. Be glad to do it. Yeah. Other questions on this particular one? Yeah. Janu?
On the homework it shows, the x minus 4.
Uh-huh.
So x is greater than, but you know how you find that with whatever equals when.
Oh, the domain.
Yeah, whatever makes x
Greater than 4 domain. Yeah, right. Yeah, so it's greater than 4, huh? So yeah, that's another way to see it. Are they asking that?
No, that just shows that.
Oh, is that what they do? Yeah, that's so fancy. I wouldn't do it that fancy. But yeah, that's true. That's true. Yeah.
You make that so it'd be x will be greater than.
They actually did both the domain things and then said this okay?
They just show you that x will be greater than 4.
Right, so then it's.
Maybe you plug the 4 in there, it'd be equal to 0, then so x is greater than 4. Then
So this is greater than 4, so.
yeah.
So ln x plus ln x plus 10, bless you. Try that one. Would you have a question? All right, try it out. This is going to have a wrinkle. You see that green? All right, so log counted. ln is the same as regular log. It's just the base of the e. So count down the logs, right? So 2 logs, 1 log, no log, like usual. So I'll probably do most of this one with you. This one has some tricks. So, okay, so 2 logs. Yeah, you can do that first step, though, first and second, right? So 2 logs added. So we're counting down the logs. 2 logs, 1 log, no log. So 2 logs added becomes 1 log multiplied, right? Good so far? Good there so far? Now, so remember the countdown. So 2 logs, 1 log. Next line we want no log. So how am I going to get no log? How am I going to get rid of the log? Yeah, because what's the base? There's an invisible understood e there, huh? So right, if the regular log were the last one, we had regular log, so the invisible base was 10. But this one we have ln, so the invisible base is e, isn't it? So, okay, so what? Well, that means you do another e to both sides, and then these guys totally cancel out. Right? We good with that? And we get what's left. X times x plus 10 is e to the 4th. Now, that's where this problem gets weird. Normal to here, weird now. But everybody good to there, though? We're out of the logs, but this is pretty weird. What is e to the 4th? Just some weird number. We're not going to type it in our calculator. It's just know, though, it's a number. E's, like pi is a 3 point whatever number. E's a 2 point whatever number. It's just a special number. So e to the 4th is just some special number. Okay, so what? What are we supposed to do? Well, we should distribute through the parentheses. So we'll get x squared plus 10x. In fact, let me bring it over here to the left. Let me bring it all the way over here. So what do we have? X times x plus 10 is e to the 4th. Distribute through. X squared plus 10x is e to the 4th. Okay. what in the world do we do now to solve this? There's no more logs. We're out of the log stuff, but how do we solve that? This is totally weird.
Move the log to the left, right?
Do what's that?
Move the log to the left.
You mean the e to the fourth?
Yeah.
To the left? Yeah. Yeah. What in general? I want to make sure you're clear in general. What's the game plan when x squared with an equal sign shows up all of a sudden?
0, 0.
Yeah, is everybody clear on that? Let me write that out for you. When you see x squared with an equal sign, because that'll happen, right? I say goofy things. I don't know why I say. Well, I know I say them so you'll remember them. But whatever. I made up a sea monster one for this. I don't have no idea where that is. But it's just like x squared just rears its ugly head all of a sudden. That's what it seems like. You're middle of solving a problem, just da-da-da, going along. Then all of a sudden, there's x squared. Rawr, sea monster. All of a sudden. Again, I don't know why I came up with sea monster. But whatever. I want to say something to key your attention. That x squared, so you're out in the ocean, suddenly the x squared rears its ugly head. What do? You want to be clear, because that'll happen all the time. Be in the middle problem, happen a lot. First step is get a 0. You want to be super clear on that. Step 1, get a 0. When that x squared rears its ugly head, all of a sudden get a 0. And step 2 is you try to factor, right? Like parentheses and all that. But that's not going to always work. Right here, it's not going to work. Right? Well, how are we going to factor e to the fourth? That's just totally weird. We're not going to factor that. So let me bump this over. So we get x squared plus 10x minus e to the fourth is 0. Okay? Now, try to factor. Not going to happen this time. So if it won't factor, or what's the other thing you can do instead of factoring? Quadratic formula. Yeah, that's what you have to do when it won't factor. That's what this one's about. This is a super hard problem. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, so you really want to have this on your 3x5 card, that x squared game plan, because it'll rear its ugly head when you're in the middle of doing something else. All of a sudden, x squared will show up. Okay. Probably watched too many fantasy movies or something. All right, so the sea monster has reared its head. We got to do that. So we look at this and we go, okay, got to do the quadratic formula. What are A, B, and C? So the A, I think you know A is 1, no big surprise there. B is 10, no big surprise there. Am I racing ahead of you? So I want you to all see the C. Okay, so what, to plug into the quadratic formula, we have to identify A, B, and C. And we had to get 0 first. It's all about 0 first. We got our 0. Then A, B, and C are the three things on the left side. What is C? It's that whole negative e to the fourth. That whole thing is C. Why? Well, it's because we use everything but the x squared and the x, don't we? Right? When you peel off A, B, and C, the only thing you're leaving behind is x squared and x. That's what you always do. Everything else you grab for A, B, and C when you do the quadratic formula, right? So that's weird, isn't it? That whole minus e to the fourth is C. So now let's plug those in to the quadratic formula. Okay, so here we go. I'm going to do the quadratic formula right here. So negative b, what's b? 10. Plus or minus the square root of b squared. So that'd be 10 squared minus 4 times a times c, which is that weird negative e to the fourth, all over 2a. Get to there. Okay, now we start cleaning this up a little bit, but this is going to require some pretty fancy algebra work. Let's go through it. Negative 10 plus or minus the square root of 10 squared, that's 100. You caught up with me? I want you to see this. What's going to happen? What's going to happen here? What is negative 4 times positive 1 times negative e to the fourth? Those are the three things we're multiplying behind the 100, right? 10 squared, 100, and then subtract But it's two negatives actually, isn't it? Multiplied together, so it's going to actually become add. What? 4e to the 4th. All over 2 times 1 is 2. Good so far? Okay. At this point, how do we simplify that? There's not a million. There's probably 3 or 4 things that you could do wrong in simplifying, and one thing you could do right. For example, could I add those? I'm going to show all the wrong things. So you can just say no every time I give an answer for a while here. Could I add those and make that 104e to the 4th? No, why not? Why is that not okay? What algebra law? I want to make sure let's review the algebra laws here. This is what this class is a lot about. Even calculus is about really becoming a master of algebra. So what law says no? What algebra law says no? Like terms. Those aren't like terms. You can't add things that aren't like terms. That's just if that was 100e to the 4th and 4e to the 4th, then I could add them and be 140e to the 4th, right? If they were like terms, they're not like terms. You can't add plain numbers with things that have letters, right? You can multiply non-like terms or divide them, but you can't add them or subtract them. So no, that's a big no-no because of the like terms rule. Okay, well let's just, here's wrong step number 2. How about we just square root, this one's probably more, most people wouldn't do that last one, but this one I've seen a lot. How about we just square root that 100? Square root of 100? 10. Square root of 4e to the 4th? 2e to the 2nd. Just square root them. No. Illegal procedure. The algebra cops will pull you over. What's illegal about that? What algebra law says no there? It's the adding and subtracting. When you have adding and subtracting, you cannot square root the individual parts. If that was times, it would be totally fine. If that was 100 times that, then yeah, the square root them each. That'd be 10 and 2e to the 2nd times. That'd be totally fine. It's the adding and subtracting. And so let me pause for a minute because that's a lot of what we're trying to do in here is really make you masters of it. If you get algebra down, seriously, if you spend enough time in this class to really go through all those homework problems and really learn them, which will require really learning all these little algebra rules, calculus will not be that hard. I mean, it's kind of challenging, but it's mainly challenging because of the algebra. It's because they push it even harder. You really have to know all these little nitty-gritty things. You master algebra, calculus is not that bad. So let's talk about that. One rule, I mean, there's so many rules in algebra, right? But if I can give you one rule that'll help in 1,000 situations, then I'll do you a lot more good. And that rule is pluses and minuses cause trouble, basically. I know it sounds really general, but it's almost always true. Things that are added and subtracted in algebra, you can never do anything nice with them. That's almost always true. It's almost like the golden rule of algebra. So one more time. I've called it Costco before, haven't I? Right? Plus and minus, so it glues things together. It packages things together. And so it means you can't cancel them. It also means you cannot root them individually. Anything nice, pretty much anything real nice and quick and simplifying, not allowed when they're added or subtracted. Fine if they're multiplied or divided. Not for adding, subtracting. So basically, if you just have in your mind, and there's so many algebra rules, but if you just have that one idea in your mind, when you see, back over here, when you see that plus sign right there and you're tempted to square root that 100 and square root that 4, you just think, look, they're added. I'm sure I can't do it. Right. That'll serve you well in so many situations. Adding, subtracting, nothing nice ever is allowed. Why, by the way? Why? Why is nothing nice ever allowed, adding, subtracting? Well, it's just not true. You know the rules of algebra, right? I could just give you an example. Square root of 4 plus 9. Is that really 2 plus 3? Is that really 5? Is this really 5? No, it's square root of 13. It's not 5. See, it's just not true, huh? It's just simply not true. So anyway, so pluses and minuses, nothing nice ever works. So I can't square root them. I can't add them. Well then, bless you. What do you do then? Is there anything to do? Let's talk about what's right to do now. Do we just do nothing? Do we just leave it? No, we do have to do something. Do you know?
You could put it to the half power.
Right, but that's just a different look. That wouldn't simplify anything. That's true, but not really helpful. Different way to say the same thing. Factor out the 4. You do, because why would you think of factoring? Why should you think that way when you're moving on into calculus? Because factoring means write it timesed. That gets around the adding problem. You get the idea? That's why we're obsessed with factoring in algebra. Because if you factor something, you make it multiplied. And you get around all the adding, subtracting problems. That's why it's a good idea. So you look in here and you go, oh, they have 4 in common. I can factor out of 4, and then it'll be 4 times, and then I can root the 4. Yeah, that'll work. So let's do that. That's the right thing. Here we go. So negative 10 plus or minus the square root. Factor out that 4 in there. You like with parentheses, you know what I mean? 4 times what will go back to 100? 4 times 25. And 4 times what will go back to 4e to the 4th? Well, just e to the 4th. Everybody see what I did? Yeah, you can't really read it very well. Let me go to fresh screen. So 10 plus or minus square root of 100. Okay. Oh, what's that? 10 plus or minus the square root of 100 plus 4e to the 4th all over 2. Is that right? 4 to the 4th over 2, yeah. Okay, yeah. So what I'm saying is, this is the conclusion to number, whatever this was, 11. So this conclusion number 11 here. So what I'm saying is, inside that square root, factor out the 4. They both have 4 in common. If they had nothing in common, say this was a 99 instead of 100, then I would just leave it. I'd just be done. That's just the answer. Can't do anything else. But since they have 4 in common, 100 and 4 goes into both of them, you do that. Now, why is that so great? Because now that 4 is timesed, which means he's yelling out, you can do nice stuff with me. I'm not added. I'm not glued to anything. So I can square root just the 4. What's the square root of 4?
2.
2. That's just 2. That just pops out as a 2. 2. The rest of the stuff, nope, we just got to leave it because, again, it's added, right? I can't square root that 25 to be 5 because, why? It's added. I can't mess with that e to the 4th. It's added. They're stuck together. Don't mess with them, right? But the 4 we did. Get the idea? Adding, subtracting, don't mess with it. But multiplied things you can do, and that's why we factor all the time, because that makes them multiplied, and then we can do nice stuff. Okay, so now we're to here. Is there anything else? There's even one more trick. Can I cancel those 2's?
Yeah.
Just those 2's?
No.
I got to also cancel the 10, huh? Because, again, plus and minus is glue, which means they're saying, I'm a package deal. If you mess with this side, you better mess with that side. We're a package deal. So as long as you divide the 2 for both of them, it's okay. That'll be a 5. That'll be a 1. That's okay. So 5 plus or minus 1, square root of 25 plus e to the 4th.
It was originally
Oh, was it? Did I mess it up?
You have it negative there.
Oh, negative the 10. I see what you're saying. Negative the 10. Thank you. So negative on the 5 now. Thank you. Yep, that's right. All right, so we good to there? Now, those are 2 answers, do you realize? In fact, let me bring it up here. We're not running. This problem goes forever. It's all this algebra rules. So, the 2's gone from the bottom. So we're to there, right? Now, those are 2 answers. That's negative 5 plus the square root of 25 plus e to the 4th, or negative 5 minus the square root of 25 plus e to the 4th. Look at this one. Bye-bye. He's negative. Do you see how he's... I don't care what e to the 4th is. I know that thing's negative because it's a negative number minus this stuff, which is positive stuff. So a negative number minus more positive stuff, that's negative. We can't put a negative. If you go back to the original question, remember the check? If you check a log, when you check the log, the inside can't be negative. Go back. You can't, right there, when you're going to plug into the original, you can't put a negative thing in there. So that one's out. The other one is the only valid answer. And they want you to type it in just like that. That's the exact answer. They want exact answer, which means they don't want a decimal. They want it just like that. Question, Carissa?
Yeah, I have a question. So the 2 on the outside of the root, this might be a dumb question, but the 2 on the outside of the root, is
Here?
that like a multiplication to the
Yeah, 2 times, exactly. Yeah, and that's because the 4 was a times. So when the 2 pops out, it's a times also.
So when you make it into a 1, you're not having to do 10 plus or minus 1. It's 10 plus or minus 1 root something, right?
Right. Well, right. It's negative 10 plus or minus 1 root whatever.
So you're not doing the 10 plus minus 1.
So in other words, you're saying you're not. So Carissa's question is good. Everybody hear it? It's like she's saying, no, you're not supposed to go negative 10 plus 1, which would be negative 9, and negative 10 minus 1, which would be negative 11.
Yeah.
Right?
You're not supposed to do that?
You're not.
Never.
Why not?
Because the one's attached to the root. Right?
Because of the order of operations. This is times. which must be done before adding and subtracting. That's the reason. So I can't do any adding and subtracting before I deal with them.
Okay.
So yes, it's attached in that sense, yes.
I understand that.
Good question. Yeah, please ask that stuff. That's how I learned too. I went and asked my teachers millions of algebra questions. And then I learned. Any other questions I can answer on that? Is that all good? That was a tough one. That's probably the hardest one in the homework. Okay. All right. So, or I'll just leave that one up as it is. Bless you. So, you know what to do. Log countdown, huh? 30 minutes to work through that one. Countdown log. Two logs, one log, no log. Feel free to compare, check with those around, just see if you know what to do about the 1/5. It's kind of weird having a fraction base.
what?
So I wanted to do this in.
That would just be 5
Yes.
because that's a
One shift to the negative one.
Oh, it would be positive 5 because that's not going in negative 5, literally, so negative 10 it would be positive.
I haven't got that far yet, and I won't know, so I don't even know.
Where you at? What'd you do?
Oh, no, he answered my
You-
question.
Oh,
I don't know the answer to it, so.
Now I'll change it to 5.
good. Exactly. Right.
Like
Yeah, because negative powers flip, don't
Would it
they?
be a negative
Yeah.
5 or just 5?
Just 5. Yeah, the negative just flips. It doesn't go to the front. Yeah, good question.
So 1/5 to the 1 power, or you need that?
So 1/5 to negative 5, that would just make it regular 5.
Oh, there's so many.
The negative one
Yeah,
is
that negative makes
opposite, flips it, okay.
See, I'm stuck right here.
Right.
Would be possible.
Yeah, exactly.
You would just.
Yeah. Good job. Question?
Oh, no, so just, no, it's
Yeah, I would, there's the sea monster root, so we had to get 0 on one side.
oh.
First step's get a 0. Whenever x squared shows up. All right, so logs, count them down. 2 logs, 1 log, no log. So we see these 2 logs subtracted. So what does that mean? It's going to become 1 log. We don't change the base. The weird 1/5 base, that'll stay. So 2 logs subtracted becomes 1 log divided. We good? Going to divide. So x squared plus x over x squared minus x. Good to there. So far, so good. So 2 logs, 1 log. Next line, we're supposed to go to no log at all. How do we go to no log? Yeah, whatever the base is, which is that 1/5, we got to power that to both sides because that way powers and logs will cancel. Good. It's opposite. Okay, so then what does that leave us? X squared plus x over, let me move it over here to the left. So we have, over here, we have x squared plus x over x squared minus x is, what is that then? 1/5 to the negative 1 power. What happens on that right side? What do negative powers do? flip it, right? And so it becomes regular 5. It's not negative 5, is it? Negative powers do not put negatives in the front. They just flip the thing, and they're gone. No, I've noticed with Chinu, he was doing the homework, he had like a negative 2 power. What if that was a negative 2 power? What would that do? It would flip it. You know, the negative part of the 2 would flip it, but then the 2 would still be there. It would be 25 in the end. Is that good? Makes sense? So the negative part of the power does the flipping, and then whatever the other number is just the power. You know, you just do it. So it'd be 5 squared 25. All right. But we just had negative 1, so the negative flipped it, and then 5 to the 1, that's just 5. So. Okay. So now, where do we go from here? Yeah, good, because we're out of the long stuff. Now, when you have fractions, you put this over 1 and go diagonal, diagonal, right? Whenever you have fraction, diagonal, diagonal, cross multiply. So what do we get then? We get 1, or I can write it down here. 1 times x squared plus x is 5 times x squared minus x. And then you distribute, and what do you get? You get x squared plus x. You get 5x squared minus 5x. To there? Yeah.
Before cross multiply, would you be able to factor it? No.
It's actually okay to factor, but it actually wouldn't be helpful. Because if we did that, we would end up undoing it. Because what we really need to do now is, well, you tell me, what is our, when we see this, what's our game plan? What should a... Good, because that's the sea monster. That's the sea monster, right? There it is. We're just out on the ocean doing our thing, and we're just solving this problem. There it is. I'm trying to say weird stuff so that you won't fall asleep, but instead you will remember. You'll remember that in the next test, maybe. I don't know. But anyway, x squared, right? Get a 0. That's the game plan. When you see that x squared, you have to get a 0. Yeah, that's why we don't really want to factor anything, because our game plan is to get a 0. So so we see x squared, you go, oh, there it is. There's the monster, get a 0. So now we'll get a 0 where? It doesn't really matter where. You get it either side. That means get rid of everything on one side, right? If you want 0, you want nothing on one side. It doesn't really matter which side. I usually get rid of the lower one. So I'm going to get rid of that x squared and whatever's with it from that left side. So there we go. So minus x squared minus x. We're doing one side, got to do the other. Minus x squared minus x. What do we get? Gone, 0. This is 4x squared minus 6x. Good to there. So get a 0. We got a 0. We made one side nothing. Step 2 is to factor. At least you can try. Usually they factor. If they don't factor, we got to do the negative b, but they usually factor. Can you factor that right side? Parentheses, multiply? Yeah, what's the, it's not 3 terms. You guys good on the, so if that had a third, it was like plus 7 or something, then I would try the 2 parentheses, wouldn't I? If it had 3 terms. But if it's just 2 things, really always with factoring, you're supposed to look for GCF first, always. So really, no matter how many terms. So what is the GCF? What do they have in common? Yeah, 2 goes into 4 and 6, and then you take the lower x power, just regular x. So that's going to be 2x. And then how do you know what goes inside? 2x times what? We'll go back to 4x squared.
Yeah, and 0.
2x times 2x. Because out front numbers multiply, the invisible 1 powers add. Minus, and then 2x times what? We'll go back to 6x. 3. Everybody see that? Factoring is just reverse multiplying, isn't it? It's just thinking what would multiply. Everybody good to there? It's factored.
I'm assuming it's a 0.
What do you do once you have it factored? Each one gets their own 0. Do you remember that rule? Right? I want to show you that makes sense. Only if it makes sense to you, I think, will you really remember it under the pressure of an exam and everything. So if these guys, if I'm saying, hey, if I'm timesing 2 things and it's coming out 0, how do 2 things multiply and come out 0? One of them has to be 0, huh? If the first one's 0, 0 times anything 0. If the second one's 0, anything times 0 will be 0. So that means either one can be 0 to make them times and be 0. That's what this is saying. This times that, right, parentheses, times, is 0. So that means the first one is 0 or the second one is 0. Either way. Can you read that? Kind of run out of room. So, yeah, let me bring it up here since we're running out of room. These problems are long and complex. So I'm getting 2x is 0 or 2x minus 3 is 0. So then divide by 2. This is x is 0. Jump the 3 over. Divide by 2. The 3 halves are 0, but we have to check. Remember, all logs must be checked. It's really quick. Just put in the 0. 0 plus 0, that makes the inside of that log 0. Noah, he's out. Is 3 halves okay? How do you check 3 halves? Well, fractions, I would just make them a decimal in my calculator. Just divide 3 divided by 2, 1.5. And then I'd put that in over here. If you put in 1.5 here and here, 1.5 squared plus 1.5, I don't know what that is, but it's not negative. Something positive squared plus something positive is positive. So that's good. Now, how about the second part, though? 1.5 squared minus 1.5? Yeah, if you type it in your calculator, it still comes out positive. So it's okay. 1.5, I think they want the fraction version, 3 halves, is the only answer. How are we doing on these logs? We're about to move on from these. I think the rest are very similar. I mean, I'll look at them real quick, but I think...
They don't want the fraction, they just want 1.5.
No, I think they want the fraction, 3 halves. They might take either. Oh, it says fractions right here. Yeah, the blue. Look at the blue line. They'll tell you. They want fractions, so they want 3 halves. Good. I just did the 1.5 for my convenience, but they want the 3 halves. 1 log on the left side, 1 log on the right side. Yeah, so in this one I would say these 2 are subtracted, those 2 are subtracted, so that means division, and then division, right, like that, and then you can get rid of those logs. How do I get rid of those logs? Just make the base match. 8 of that gone, 8 of that gone, so really they're just, all that stuff's just gone. You get to here, you go diagonal, diagonal, cross multiply on that. You know what's going to happen on this one? The sea monster is going to die. The x squared will drop out. It'll actually be nice. It's not a bad one after that because you get the left side, you get the right side, right, cross multiply, boom, boom, FOIL, x squared plus 4x, boom, boom, minus 8x, minus 32, right side, boom, boom, x squared minus 3x, boom, boom, plus 1x minus 3. And then notice, well, let me do one more step here. We have x squared, 4x minus 8 is minus 4x. Other side, x squared minus 3x plus 1x is minus 2x. Notice you have x squared on both sides. If you have the same amount of anything on both sides, it's just going to drop out, huh? Because you just subtract x squared from both sides of the wall there, and it's gone, and it's gone. So it's nice. The sea monster goes away. The x squared goes away. You're just down to a regular x equation now. No more x squared. So that means you don't have to do 0 and factor and all that fancy stuff. It's just regular x now. There's no sea monster. So just solve for x, right? Just get x alone however you want. There's a million ways to do it. I would just probably add 4x to both sides. That'd be what? 2x minus 3. Add the 3. Whatever that is. Minus 29 is 2x divided by 2. There it is. Minus 29 halves. Oh, no, that's a bad answer. Ha! This is no solution. All that work, no solution. Do y'all see that? So how do I know that? I'm putting in right there minus 29 halves. I don't know what minus 29 halves is, but it's negative. Take away 8, that's still negative inside a log. And that's my only answer. Crossed off. What does that mean? There's no solution. All that work. Note it. For number 14, it's no solution. It'll be the same for you. Yeah. Right. If it violates any one of them, it's out. That's right. If it makes the inside of any log 0 or negative, throw it away. Is exponential equations, powered equations. So no more logs. Now, right, this doesn't have any logs. Notice we just shifted gears. No logs here. But now we've got x climbed up into the power zone. I would say Hitler climbed into power, right? So we got to get him out of power. We got to get x Somehow we're going to do something like that. So what we've had this once before, right? Make the bases the same. Remember how we learned to make the bases the same? That's like a trick which almost never is allowed. This will be the only one that you can make the bases the same. The rest of the homework we'll have to do something else. So I'll just do this one and then I'll show you what I mean. So 36 is 6 squared. I made the bases the same. So what? What do I do now? What does that do for me?
X minus 5 equals 2.
Yeah, those powers must... That means that for sure, logically, those powers have to be... What? Because if they were different, 6 to one of them wouldn't be equaling 6 to the other. If they were different, they have to be equal. Powers have to be equal. Once you made the bases the same, you know the powers are equal. Right? And so then add 5 to both sides. X is 7. So that's like a trick one. Right? What do I mean trick one? Well, what if they just made that 35 instead of 36? Then you couldn't do that. You couldn't make that a 6. You see how they made it just perfect so that we could do that little trick? It's really a cute little method, but it's not going to really. When they build bridges and do science in the real world, that doesn't work. It don't come out, yeah, it came out perfect. Same bases. No.
So what would you do if you couldn't make it?
Yes, that's where we need. So 2 to the x is 7. Yeah. How are we going to solve that? Those bases aren't the same. You're not going to make 7 2 to something, right? It's more like real life here. This is what happens in the real world when they do science. When they use math to do something real. Bases don't come out the same. So, how do you solve it? A lot of financial problems. Business world, if you go into business, they do there's a lot of problems you solve with x's in the power zone like this. Because of the equation. We'll see next section. Today even. We'll start 5-7. You'll see. We'll see exactly that. We'll see financial problems, real life, x in the power zone a lot of times. So how do we solve x in the power zone here? How are we going to do it? First off, do you appreciate the I think if you feel the difficulty of it, you'll remember the way to do it better. What I mean, let me help you appreciate how difficult it is. I can't divide by 2. It's not 2 times x. It's 2 to the x power. So dividing isn't going to do it. Square root's not going to do it. Well, why would square root not do it? That's only if the 2's in the power. That works great when 2's in the power. Not when x is in the power. That won't work, will it? Can't square root it. Can't divide. Do you see how just like nothing normal works? Do you see how it's really difficult when x and the particular problem is that x itself is in the power, not just that we have powers. Like I said, if it was just like that, no problem. Just root it, Root it. Roof in the house, up and down the ladder. No big deal. If just got numbers in the power. But if you got x itself, if Hitler himself, that was the problem. I'm trying to connect you with history, right? There's people today that would agree with everything Hitler wrote in, what did he write? Mein Kampf, or whatever that book he wrote, his autobiography, right? There's people today that would agree with every bit of it. They're just not in power, thankfully, right? The problem is when they get in power, right? That was a problem. So the problem is the x is in the power zone. That's the problem. What do we do? All right, so that's all the stuff we don't do. What do we do? What takes powers down? Logs. Remember that third property of logs? That's why we say that's their best quality. It takes that power down to the front. Remember that? That's why the answer is ln on both sides. So let me write that. When x in power, Hitler climbs into power, ln both sides. And powers, scribbly there, powers down to the front. Powers down to the front.
Why is it ln, not log?
Good question. You could do log. Regular log would work just fine too. I'm going to use ln all the time because in a few minutes, one of the problems will have an e. And then when e shows up, ln completely cancels it. So it's just more convenient. But regular log would work just as well for all these and not quite as well for the e ones. Although it still worked for the e ones too. So just for more convenience, I'll use ln because later an e's coming. So, right, see that quality? Power comes down to the front. Power comes down to it. Now, Hitler's out of power. It was no problem. It was no problem. I just listened to Churchill's biography a few months ago, finished it. Anyway, and I heard they talked about that last part where Hitler was out of power. His men didn't obey him. They were like, whatever, buddy. We're not obeying you. The Russians are at the door. You have no power.
You just drive around.
So what do we do? Now X is out of power. What do we do? What's that?
You drive around and listen to books.
I do. I like to listen to biographies as I drive around. I think they're really cool. Think about doing Napoleon next. I'm trying to get my son to do it with me. He's into Napoleon. Anyway, we're just a little weird, I guess. I want to get to a different century. Anyway, so Napoleon was a very interesting character. Anyway, sorry, this is math. Here we go. I like history. Math. So X is out of power. X is out of power, so it's cake now, right? How do we solve for X now? Just divide. That's just times. It's no big deal. Once X is down, once X is out of power, that's just X times ln2, done. I had a good question in my last class about this step right here. I hadn't thought of or heard that question before. It's a really good question. Somebody asked, they said, Mr. Heron, you're always beating the drum that we can't divide by log stuff, and then here you're dividing by log stuff. What's going on? You know how I have said things like that, like don't divide by logs, it's not multiply. So I think I could say that a better way to be more helpful. This is totally fine to do. What you cannot do is separate a log from his plug-in. I should probably say it that way. That's a better way to say it. Meaning, let me show you one that you can't do. Like if you had ln x is 3 or something. You can't divide by just the ln. That's what I mean you can't do. Because that x is his plug-in, huh? That's in the toaster for him. You can't separate ln or any other log, or regular log, any kind of log, from his plug-in. You can't. It's not times. That's in him. That's in the toaster. That's what you can't do. So you can't separate a log from his plug-in. So this would be a legal procedure. But this right here is fine. What I'm doing here is fine. Because I'm not separating the 2 from the ln. That's still in him. That's fine. I'm just dividing the ln2, the whole thing. That's totally fine to do. There's the answer. We're done. So X in power, L in both sides. Bring the powers down. Yeah?
So when I initially saw the question, the first thing I did was just change around, base stays the same, and the other switch. So I rewrote it as log base 2, 7 equals X. Isn't that basically the same except with ln? X equals, when you put it in the calculator, it's...
Totally. Yep, that's the other way. You're totally right. Yeah, I'll just say what you're saying. Yeah, you're looking at this, and you said, I use that other rule that I said before. I'm actually trying to get away from it because I think this is easier for people, but it's still true, and that'll totally work fine for you. The base stays the base, the other 2 switch. So you just said, look, I do this, the base is 2, the other 2 switch, the 7 goes here, X goes here. Totally right, and X is alone now. And then what is this? Well, the top goes top, the bottom goes bottom, just like you're saying, which is the same as that, isn't it? Oh, and log and ln, it'll come out the same in your calculator. And MathXL knows it, and they'll take it. You're right. All right. Yeah, remember what a good question, Krista? It's the easier job for 2. Mm-hmm. So subtraction for 2 would become dividing for 1.
Got it. Okay.
Right? So this is dividing for 2.
Okay.
So we can't make that into subtraction for 1 because that would be an easier job for one person. No, it doesn't flow that way. Okay. Yeah, good question. Okay. So let's try this one. It's just flashed off. The projector's getting tired. All right, so try that one. So Hitler's climbed into power. Hopefully you remember my goofy analogies. X has climbed into power. So you think, all right, got to get it out of power. Got to get it out of power. What's gonna get it out of power is ln. But should we do ln right now? What are we gonna do first? We don't want to do ln right now. Get that 3 out of there. Yeah, because you want to get that 3 is kind of like protecting the base. You want to get it out of there first. Yeah, exactly. So that's why I wanted to show you one like this. So first divide by the 3 on both sides, right? Get that base alone exposed, and then ln. Right, ln. Got to bring down the power. What brought down Hitler was the Russian army mainly. Do you know Stalin emptied the insane asylums and enlisted them as soldiers during World War II and sent them into the battle with Germany? And they did some scary stuff, but they did beat Germany. Anyway, I think history's interesting. Stalin was worse than Hitler, I think. But anyway. And Hitler was kind of counting on that. He thought we, as America, would not side with Russia because, they were philosophically different than us too. Anyway, I'm not a history teacher. I'm just a wannabe history teacher, no more. All right, L in both sides. L in both sides, bring that power down. Bring that power down. Right, so we get the base alone, L in both sides, bring that power down. 8x down to the front. Like that. And once it's out of power, now we can just divide. Am I going too fast? Are you good there? So x in power, get it alone, and then L in both sides. Power comes down. He's out of power now. Now it's easy. Once it's out of power, it's easy. It's just a divide step. Because that's just I don't know if that seems clear to you. It's just 8 times x times ln 2. Those are just multiplied now. So it's just divide them. Just divide by both the 8 and the ln 2 all at once. 8 and ln 2. Gone. X is alone. We're done. Now let's do that in our calculator as well. They want both. See how right here they say exact solution first? They want the exact solution, which means they want exactly that. No decimals, because that would be rounded and not exact. So they want the exact first. They want you to type in exactly that. Next, this part B, they're going to ask for the decimal. So can you get the decimal in your calculator? I'll get it too. Remember when you type that into your calculator? Remember when there's more than one thing in the numerator or denominator in any zone, you've got to put parentheses around that zone when you type it into your calculator. So you notice there's 2 things in the bottom. You're going to have to parenthesize the bottom because there's both an 8 and an ln 2. There's 2 things. You've got to parenthesize that denominator. So in other words, the way you type it on your calculator will be like this. ln 5 divided by 3 divided by, let me use a different color here, parentheses, 8 ln 2. See how I've got double parentheses there? That's what you're going to want to type in. Let me see what I get here. I'm getting, I don't know how many decimals. 0.09212, 0.0921206, blah, 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 blah. You guys getting that? Did they say 3 places?
Yeah, last section they were saying to the thousand.
Yeah, I think it's 3 places. They probably just want 0.092. Be able to get that on your calculator? That makes sense. So really want to remember, it'd be a bummer to all this good work and not get the right decimal on the test or something, Parentheses. When there's more than one, there's an 8 and an ln 2, there's 2 things. So parentheses, when there's more than one thing in a zone, top, bottom, power zone, parentheses. That's the only way the calculator knows you're saying all of this is in the bottom. It won't know that otherwise. Unless you have one of those fancy calculators that just shows it like a fraction, then you don't need parentheses. It knows. But mine does it all in one line. If you have it all in one line, you need to tell it what the zones are. Okay, good? I'll move on. Questions? Here. And then they'll get easy, their calculator, and we're done with the section. So let's try that one. I'll help you through with this one. In fact, I'm going to go to a fresh screen. I don't have any room to work there. So number 19, let me just put it right here. What is it? 2 to the 1 minus 7x, 3 to the x. 2 to the 1 minus 7x, 3 to the x. Is that right? Yeah. Okay, so there it is. There's number 19. Let's solve that. So we see x in power, Hitler's in power. What's going to bring it out of power? L in to both sides. So that's our first step. L in both sides. And then we grab, well, what happens when we do a log in ln or any other log? Power comes down, right? So I grab the whole power, bring it down, the whole power, bring it down. So I get 1 minus 7x ln 2 is x ln 3. I've seen it written that way a lot, and that's wrong. I've done something wrong. It's small, but it doesn't matter. What's wrong about how I just wrote that? It's almost right. Gotta have parentheses. Yeah, if you realize that you absolutely, positively must, it's not optional, it's not decoration, you must have parentheses around that 1 minus 7x. Why? There was never parentheses before. Why is that suddenly required? Because if you don't put the parentheses, then what this means is the 1 is totally on its own minus 7x times ln2, meaning only the 7x is multiplied by the ln2, not the whole 1 minus 7x. Well, why is that a problem? Well, because the whole 1 minus 7x was in the power, thus the whole 1 minus 7x must be multiplied. So parentheses indicate that, don't they? So you must do that. All right, so anyway, what do we do now? Well, now that we know there's parentheses, that tells us we're going to distribute. That's what you always do with parentheses, huh? You distribute. Now that ln2, don't let that throw you off. That's just a number. You can get that in a minute on our calculator. It's just some number. So it's just like you got a number in front of parentheses, you distribute. That's what we always do with a number in front of parentheses. So 1 times ln2 minus 7x ln2 is x ln3. No more parentheses. Whenever you multiply through parentheses, they vanish, don't they? When you distribute through parentheses. What's up from the outside of parentheses goes in, distributes in, they vanish. So they drop. No more parentheses. Now, this one's harder. We're trying to solve for x. How do we solve for x? What do we do? Do you see this is another thing. We did it before with inverse functions. What I mean is, we recognize there's a certain thing you want to recognize. A lot of math is recognizing the whatever and then remembering the pattern to handle it. So what am I saying recognize? There's something special about what we're looking at right now. Trying to solve for x, and what's special about x? What's weird about x? 2 places. X is here, and it's there. What have we learned to do when x is in 2 places? Get them on one side, factor out the x and divide. Remember with inverse functions, we had a few of those? So so that's another game plan you want to be really clear on. When x is in 2 places, number 1, you get them on this, get them on the same side. Step 2, factor out the x and divide. Yeah, so it doesn't matter which side, right side, left side, whatever. I'll just grab this term and jump him over here. He'll become a positive on the other side, right? So then I have 1 times ln2, that's just ln2. Over here I have x ln3 plus 7x ln2. Are we good so far? See how the 2x terms are on the same side now? So the 2x terms are on the same side. Now we factor out the x. That's how you get it alone, you see? See how that isolates it? Get them on the same side. Yeah, and then we just divide. Divide by that whole big ugly ln3 plus 7 ln2 thing. Boom. X is alone. Can you get the decimal on your calculator there? When you type that in, remember the denominator has more than one thing, so that means you got to put an extra set of parentheses around the denominator. That'll be in addition to the little parentheses that always go on the argument of ln's. Like that. That'll be what you type in, right? Can you do that real quick? Getting that 0.11648 thing? Good there. Is that okay? Questions on that one I can answer? Very good. So this will come up a lot. Even in calculus, come up a lot. X in 2 places. Get them on the same side. Factor out and divide. All right, I'll move on if you're okay. Okay, let me put this on a fresh screen. So this is number 22, pi to the 1 minus x. 22. Pi to the 1 minus x is e to the 7x. Okay, e. Now remember, pi and e are just numbers, aren't they? Well, we're going to leave them pi and e. We're not going to put their numbers in, but, you know, there's numbers. X, the big deal for us is that x is climbed into power. And losing power, going to get them out of power. So L in both sides, right? X is in power. Got to get it out of power. L in both sides. L in both sides. Like that. L on both sides. And then the powers drop down. That's the great quality of logs. They bring powers down in front. That third property is their best property. So, and then you got to put parentheses. And what's the ln of e? Just 1. So it's just gone. That's why I'm saying it's so convenient when ln and e get together. They're just gone. There's 1. ln of e is 1. They're opposites. So it's just gone. So far. So you got those parentheses. See, I put the parentheses on the left side again because the whole 1 minus x was in the power, so the whole 1 minus x needs to multiply those parentheses. So distribute through those parentheses. So 1 ln pi minus x ln pi 7x, right? Distribute through the parentheses. Good. Ln pi is just a number. We'll get it in a minute. Okay. So you know what you do now? What jumps off the page? What's special about this? A lot of math science is identification. You want to see it, you go, oh, that's one of those. What's special about this? X in 2 places. X in 2 places. You say, oh, yeah, X in 2 places. I remember the steps. Get them on the same side, right? So I'm going to jump this over here like that. This term. So it'll become a positive x natural log pi on the other side. So ln pi is 7x plus x ln pi. Good to there? And now what do we do? Factor out the x and divide, huh? Boom. X is alone. There's our answer. This making sense? Hey, can I you can tell if the answer is no by my tone. Can I cancel those L? Why can I not cancel those ln pi's? Glue. Adding. Same thing as always, huh? Glue. Costco glue. Plus and minuses. Nothing nice. Yep. Has to stay just like that. If that was times on the bottom, I would totally cancel those ln pi's. That's the deal. And then they want a decimal one too. So oh yeah, let's go to decimal because yeah, when you do let's do that real quick. I forgot that is important. Well, let's do the decimal now because when you do the decimal, you got to use the pi button. You don't want to just type in 3.14. That's not accurate enough. Remember, pi goes on and on forever. So you want to use the pi button on your calculator. So let's see if you can get that going. The pi button is above the up arrow, at least on the TI-84. Right middle. Right middle is above the up arrow, at least on the TI-84. That's where the pi button is. So use your pi button. Hey, that's tomorrow. Yeah, it just occurred to me. We are close to that. That it's Pi Day. I think it's a little weird. But some people are really, don't they have like a big parade in San Francisco usually? For Pi Day? I think so. It's a little too much for me. That's a little strange. But March 14, 3/14, yeah. That's a little weird, but
It's all business strategy.
Yeah.
is it a business? It probably is. Totally.
Oh, it's
Yeah.
Pi Day because it's
National
3/14.
Pancake Day, National
Tomorrow's
Pie Day.
3/14. It's 3.14 Pi.
Yeah. Yeah, 3.114 March.
My
March
daughter's
14.
preschool grades up anyway.
Did they?
I don't know if she does this year.
Tomorrow's the day. 0.1405. So I think it rounds to 3 places, 0.141. You guys getting that? Okay, using the Pi button and everything? Is that good? Questions on that? Yeah, so you didn't put parentheses around that denominator. So remember, you got to put extra parentheses around that denominator because there's more than one thing down there. Whenever there's more than one thing, you have to put parentheses around.
What was it?
1.141?
Yeah.
We good on that? Questions? So if you have trouble with the calculator, come up after. And I can straighten that out with you in 10 seconds probably. Just bring it on up afterwards. So we have log 4 x plus 1 minus log 2 x minus 2 is 3. All right, try that one. This one's got a problem. Do you notice?
I know, but you can make it log 2.
Different log bases, right? Do you see how the bases don't match? One of them is a log base 4, and the other one is a log base 2. They're not the same, so we can't use the properties. The bases, remember those 3 properties we laid out? They have to be the same bases. You can't say, well, subtraction becomes division, because what would the base be for the one log? Would it be 4? Would it be 2? Or what? We don't have a rule for that. So this one we cannot do by hand. That's why they said use your graphing utility. So I want you to see first that this one is not solvable by hand because of the different bases. See how easy it is to make up a question that we can't solve? Right? I mean, we feel like we learn, and you are learning at this point a lot of different things to solve. But really, real life, when you're doing math in the real world for science applications, it's often things like this come up that we don't have a way to solve that by hand. Technology is necessary. All right, so how do we do the technology thing? The left side is y1. The right side is y2. Type them in, graph it, hit the intersect button. So let me help you with that left side, though. Do you know how to type this into your calculator? How do you type in, like, bases that are funny, that are not 10 or not e? Yeah, what is it? There's 2 ways. I've always told you top goes top, bottom goes bottom, and that'll work fine. Or there's also on the TIs, what is it? You hit alpha.
You hit math, hit alpha, and then math again. It's a shortcut.
See it again, what's that?
Math, alpha,
math, alpha, math.
Math, alpha, math. Nothing happens on my, I think I got an old program.
It's not right here.
Then it's on the math menu.
Is it on the math menu?
Isn't it? Down at the bottom. It's A on the math menu.
The math, or the, anyway, so I think you guys have newer ones than me. So there is a place under the math menu where you can do your own log base.
Oh yeah, it's under math.
Is it under math?
Yeah.
Yes, I have an older one.
Your list doesn't continue to go down after numbers.
No, 9-0 stops. Yep. Anyway, so if you can find it under the math menu or under wherever, that's great. The way I have to do it, because mine doesn't have that, is I make the top go top, the bottom go bottom. That's the other way, just to do it by hand. So in other words, which one's the top? This guy's the top. The 4 is the bottom. So I just type it in log of x plus 1 divided by log of 4. So that's this one. And then minus, and then this one. Log of x minus 2 divided by log of 2. So that's what y1 equals. That's y1 equals. And y2 is just the 3. Everybody tracking with what I'm doing there? Remember we make the top go top and the bottom go bottom. Remember that? The top goes top, the bottom goes bottom. Same thing here. The top goes top, the bottom goes bottom, and it turns into that and turns into that. Remember that?
But if we have that.
Yeah, it'll work. If you have that other way,
Just go straight forward.
just go straight forward. Yeah, if you can find the other way, then great. Just do that. You don't have to do my switcheroo trick. So type that in for y1. Type y2 is just 3, right? y2 is the left side. y1's left side. y2 is either way. y1's one side. y2 is the other side. And then graph it on your calculator. Hit the graph button. And then do the intersect thing. And I've already got the answer on the screen there. Should be 2.22. You able to get that? Coming out with an old graph and calculator.
Where it hits, where are we supposed to be?
Yeah, once you've got them on the screen, just hit intersect. Enter, enter, enter. And you should get the 2.22. Y'all getting that? That coming up? Anybody getting that? All right, a couple of you. All right, I better move on in the interest of time, but if you're having trouble, grab me after class. Calculator stuff, 10 seconds, we can get it running. Come up and let me know. Yeah, does that make sense? Yeah, so if you don't have the special button or you can't find it, yeah, the top goes top, the bottom goes bottom, like that. 2.22. So yes, you make one, you make it, that's the rule when you have weird bases. You can just make the top go top and the bottom go bottom. Like that. All right. Last question on this section. I want to start the next one, the financial applications. Let's look at this one. So blah, 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 blah. Then they give me a formula in the middle. Let me just grab that formula. So P, I'm going to skip the parentheses to there. 286, 1.011 to the T, it's a T there, minus 2,000 power. Okay, so there we have the formula. Now, basically, if you read the question, blah, 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 they want to know 324 million people. Where do I plug that 324?
P.
Yeah, P. It says P. P is millions of people, population. So, yeah, 324. And they want me to solve for T. They're saying, in what year? So let's just solve that equation for T. That's all it is. Just plug in. So we don't really have to do anything with the words. Just plug in the 324 for the P.
That's why.
Solve for T.
Y1 and Y2.
Oh, I guess you could, or you could do it by hand. This one we could do by hand, but yeah, you could do Y1, Y2. Hit the buttons. Of course, this one could be on the no graphing calculator part because you can do this one by hand. How about I do it by hand? Hitler's in power, right? The T's up here in the power zone. Hitler climbs into power. The letter climbs into power. Going to have to LN, but are we ready for LN right now?
Divide the.
Get that 286 out of there. Remember, you want to get the base exposed and then LN it, right? So first divide by that 286. Boom. Like that. That's a funny looking 8 there. 286. Bring it over here. So we have 324 over 286, and we have 1.011 to the T minus 2,000. Okay, and now what? Now we're ready for the LN both sides, huh? ln, the power drops down, the third property of logs, powers come down to the front. So then we have ln of 324 over 286 is t minus 2,000. Got to put parentheses around that t minus 2,000, though, because it's all come down to the front to multiply. Times ln 1.011. Okay, what are we going to do now to solve for t? Yeah, you could just divide the log. I always distribute. You don't. Sometimes you have to distribute, but this one you could just divide. Be a little easier. Divide by the ln 1.011, huh? And just gonzo on 1.011. And so now we're getting close. We get t minus 2,000 is ln of 324 over 286 all over 1.011. Right? We good to there? Last step, add that 2,000 over, huh? And t will be alone. That over plus 2,000. Type that in to your calculator and you'll get an answer. I don't got time. I want to move on to the financial applications. So type that in, whatever the answer is. Well, here, maybe I could do it real quick. See, ln.
Is this one on your YouTube?
Yes, but I was told in the last class that I whipped over it really quick and wasn't covered very well on the YouTube. So that's why.
Are you going to upload this lecture to your YouTube?
Yes, this one will be uploaded.
And this will be on the written part and no graphing calculator part.
You're right. It's fair game for no graphing calculator because we can do it that way. So I got the answer 2011.4. So in the year 2011.
You can do it.
In the year 2011.
Your other calculator just can't use a graphing calculator the first.
And my other calculator doesn't
We good with that? So if you have any trouble, let me know.